Hello math20-2 and welcome back. Today we're looking at the z-score in more detail. And today we're going to look at using a table to help us calculate the z-scores. We have looked at standard deviation and the percentages and how well they worked out if the standard deviation is 1 whole or -1, or if it is any of these, any whole numbers up to 3. But what happens if our standard deviation is 0.5? Then what is our probability? Then how much is going to be under the curve? What's the area under the curve? Or the probability. So the percentage under the curve is, remember, the probability of it happening. So what happens if it's 1.5 or -1.2, or if it's in between 1 and -2.3? What will be our probability then? That's where we have a problem. We're able to figure out the z-score for that, which is just how many standard deviations away, but we're not able to calculate it yet. And we're going to learn how to do that here. So just a quick review, properties of z-score. The z-score describes the data value, or the z-score for a data value describes the number of standard deviations it is away. A negative z-score means it's below our standard deviation. It's on the left side, so it's below the mean of the value. Okay, so it's below the mean, to the left of the mean, which means it's below the mean. And a positive means it's to the right of the mean, meaning it's above the mean. Now the z-score in a table is the area under the curve, all right? So the z-score in your table will give you the area under the curve. So if we look at this here, here's a quick table. Here's a table. This is your z-score, okay? Now this tells you your area under the curve. So everything less than 3.4 or 3.49 is 0.002, that's less than 2%. Everything less than 3.40 is not even 3%, it's 0.03%. If we go over here, everything less than 0.1, so that's positive, that's on the right side. Oh, sorry, I'll move this here. Everything less than 0.10 is going to be 54%. Okay, 54%. So if I had it as standard deviation of 0.1, we want to figure out, we just have to use these tables here. And we're going to look at some examples to see how to do that. So here we go. Our first example says, on the normal curve, shave where the z is less than -3. So less than -3, that's going to be over here somewhere. This is the area less than -3. Remember, the alligator mouth opens to -3, so -3 must be bigger. Now determine the area under the curve for z -3 using the z-score table. So we're going to go back to our table here, and I want -3.0. So I go here, and I look. -3. This is 0.09. -3.00 is all the way over here. So that gives me 0.13%. It is 0.0013 is the probability out of 100, which is the same as 0.13%. Okay? So if we use our standard distribution curve above, we notice that it is the exact same thing right there. All right? Okay. So let's go on to question number 2. So question number 2 says, use the z-score tables to calculate -2. So let's use this z-score table to calculate -2. This is nice, because you will get this z-score table on your exam, and it's a way that you never have to actually memorize. So now you don't have to memorize any of these data points. So let's look at -2. So where's the z-score for -2.0? So 2.00 is -2. Go across, 2. And then we want 0.00 all the way. I gotta zoom out so we can see the whole table. We want 2.00. So 2.00 is right here, because the 00, that's the decimals. So -2.00 is right there. 2.28%. So the probability A is 0.0228, I believe. Yeah, which is the same as 2.28%. Now it wants where it is 1. So that's positive. And we shade that. That's all of this here it wants. This one wants everything less than 1. So 1's going to be around there. And we're going to shade all of that. This is what we want. Everything less than 1. Okay, so what probability, if you are 1 standard deviation away, if your z-score was 1, well, you're in the top what? Like how many people are below you? Let's see. So that's the negative. This is the negative table, so we have to go to the positive. Now look at this here. I have 1.0, and this is the second digit, 0. So I get 84.13. Put that in. So 0.8413, which is the same as 84.13%. Okay? The next one is at 2. So 2 is way over here. So we want everything less than 2. So we go 2.00, 2.00. Right there. So I'm going to get 97.72. 0.9772, which is 97.72%. Okay? B says verify your answers using the normal curve. I'll give that up to you. If we look on this normal curve here, we're going to get pretty much the same answers. So we have 215, at 2, negative 2, 215 plus 0.13, that would be plus 0.13 is, look at that, it works perfect. Then we're going to be, that's 2.28. This one here, everything less than 1, 34 plus 34, 68 plus 13. We add all those up, we're going to get the exact same thing. So this just tells you everything less. Okay, and the next one right here, we do that. We add up 13 to this one, and you're going to get that 97. All right? So the next one says, determine the area of the following z-score. So now we have decimals. And it wants to convert each to a percentage. So the last ones I converted for a percentage too, even though it didn't ask, just so we get some practice. So we want less than negative 2.15. So it's a negative, that means we're on this side, we're on the left side of our mean, because we are below average on this one. It's below the average. So we go down here, and it's going to be somewhere way down here, I say. So we go so we want it to be less than, or z-score is less than 2.15. Okay? So we want less than negative 2.15. So we go negative 2.1, and then we have to go, because 2.1, and then all the way to 5, which is right here. I look up, that's the 5 column, 2.15, which gives me 0.0158. Which is the same thing as 15, or 1.58%. So only 1.58%. This one now wants everything bigger than 2.15. So if we go right there, it wants everything bigger. It wants all of this. Well, remember from before, the total area under a curve is 100%. So we're going to go 100 subtract 1.58, which will give me 98.42. Okay? And that's it. The next one here is it wants between 2.15 and 2.15. So we want it in between these two. So we want between here and here. Okay, that's interesting. So we know this is 98%, right? Everything when z's bigger is 98%. So I'm going to have 98%, or in other words, we could go from here all the way to here is 98%. But now we're missing this 2.15. So how much are we missing? Let's see. 2.15. 2.1, go all the way over to 5. I'm at 5. No, I'm at 4. 2.15 is right here. I get 98.42. So look over. This here is 98.42. Wow, everything less than this is 98.42. Isn't that kind of interesting? Isn't that the same as this? 98.42 is that way, but 98.42 is this way. But we still have to subtract the 1.58 because it's in between here and here. So 98.42 is everything less, including this bit, and we have to subtract that 1.58. So we're going to go 98.42, then we're going to subtract 1.58, which is going to give me 96 point, oh, it's been a long day, 96.84, I believe. It might be a bit off, but I think it's around 96.4%. Okay? So basically, I found all of this first. All of this here first. That is my, what is this? Z 2.15. And then we're missing this negative 2.15. So I have to go the Z 2.15 subtract Z negative 2.15, and that's what's going to give me this whole area, because I have to take away this little bit here. Alright, does that help? Okay. And if we also notice, this positive is the same as that negative when Z is bigger than it, which is kind of interesting, because remember, it's perfectly symmetrical. Okay, example number 4. Determine to 4 decimal places the area under the curve for standard normal distribution for each of the following. So now here we want where Z is less than 2.08. So we're going to look, it just wants the area under the curve, so the area under 1. So we want Z is 2.08. And does it want bigger than? Z is less than 2.08. So 2.08, somewhere over here. And we want everything less than 2.08. It's actually probably farther than that, to tell you the truth. 2.08, so we go 2.0, we go all the way to 8, is right there, 98.12. Okay, so I put that in, 0.9812. There we go, that is our interval. So it just wants the area. Our area is 9812 out of 1. Okay, so it goes all the way this way. Next one says Z must be greater than 0.92. So we have 0.92. Oh, that's far this way. 0.92 is close to 1, so I want to say right there. And we want everything greater. Well, we're going to try something here that's going to be interesting. So let's first go 0.92, and we want everything greater than. So I'm going to take a look at that. 0.92. If we look up 0.92, it's going to give us everything here. What we want there, and the whole area is 1. So we're going to go 1 minus the Z of 0.92, because we want everything bigger than that. Okay, which is 1. Subtract, what is the Z score of 0.92? Quick look. 0.92, which is 82.12. Okay, 0.9900, 0.90, 0.91, 0.92 is 82.12. So I go 1, subtract 80.8212, which will give me, if I subtract this, it's going to give me a total of 0.1788, I believe, 88. Now, let's see if I looked at the negative score of this, because remember, these are symmetrical. So if I looked at the negative score, it would tell me this part here. And these are symmetrical. So I would say that this should be equal to that. But let's double check. I think it will be. So if I go negative 0.92 is all the way here, and it's 0.1788. What, do we see that on there? Let's see, 0.1788 right there. Okay? And look at that, that's exactly what we got, because it's symmetrical, just like what I said. So if I look at this, we're saying it's bigger, that's this side, that's the same as this being negative and being smaller, because the bell curve is always perfectly symmetrical. It just goes symmetrically. Okay? So let's take a look at this one. It says Z wants to be greater than negative 1.75, so greater than negative 1.75, that's far away here, and negative 1.02. So it's greater than this, all the way to here, but less than that. So we want this shaded area there. So the way I look at this is we want everything less than 1.02 first. We're going this way because it always shows us going left. It always shows us going this way. So we want everything less than 1.02. So we're going to go Z, or probability, Z, 1. We're going to just go the probability of 1.02. Then we're going to subtract whatever the 1.75 is. And they're both negatives, right? So let's first look up the 1.02. So negative 1.02 is right there, and I get 0.1515. Now let's look up the 1.75. Okay, so let's take a look. 1.7, negative 1.7, and we have to go all the way to 5, which is right here, and that I get 0.0401. 0.0401. So now if I subtract that, I'm going to get 0.1114. Do I have too many ones? 1, 2, 3, 4. There we go. So that's how we do that one. Okay. Second last set of questions. This one here says determine the probability. Find the following z-score intervals. So this next one here says find the probability of each of these. So we want to find the probability for each of these here. Well, this is the probability of each of this. This is kind of what I did there. So we want 1.83. Now, okay, so we want the probabilities. Now, as soon as we do probabilities, it's a little bit different. So we have negative 1.83. Well, negative 1.83 is there, and we have 2.65. It's different kind of, but almost the same. So what is the probability? 2.65 and 1.83, well, it's going to be somewhere here. Now we want everything less than this, all the way to that. So this is negative 1.83, and this is 2.65. So let's check that out using my z-score table. So first we're going to go this one, because we want everything less than that, and we're going to subtract that. So go 2.65. 2.65, and that's positive, so I'm going to go here. Positive 2.65, just I think that's what I want. Yep, 2.65. We go 2.6 all the way over to 5, which is 0. It's 9960. 9960. Okay, we have 0.9960. Now we have to subtract negative 1.83. Negative 1.83. So let's put this here. Negative 1.8. And we find 3's all the way over there. 1.83. 0.0336. And we subtract those, and I'm going to get 4, 5, so 4, 5, whoopsie, 4, 5, 4, 2. You guys are going to think I'm going crazy here soon. 4, 2, 6, 9. So 9642, 0.9642 is going to be our answer. Now we look at the next one, we do the same thing. So we want 2.65 is right here, 1.83 is going to be somewhere right there. We want to find this percentage here, so we always go bigger and subtract the smaller. So we have 2.65, whatever that probability is. Oops, I'll put the 2.65 and 1.83, and we want the probability in between. Okay, so 2.65. 2.65 is on this one, and the positives, I don't know why I was looking there. So we go 2.6, and we go all the way over. 5 is 99.60. We found that out actually before. So we have 99.60. And we're going to put this over here. And what was the next one? 1.83. So we go 1.8 all the way 1.80, 1.81, 82, 83, 96.9664. 0.9664. Okay? And we just subtract those, and that's what we're going to get our answer. I'm looking at this. It's going to be, I would say, I got that, so I'm going to get 6. So I get 0.0296. 0.0296. That's like 2.96% if we do that. All right? So that's how we do that little bit there. So basically, probability and area under the curve are more or less the same thing. Next one. Last few questions. So this here is the exact opposite. We're going to try. We can use our z-score tables to determine the z-score for each. So here we're looking at 17.62%. So we want 17.62%. Okay? I look at that now. 17.62. I know it's on this side, so it's a negative. I'm going to look at my table, and I'm going to find a negative that is 17.62%. So that's 0.176. So 0.14, 18, 0.174. Nope, that's one way off. 0.1762, right there. That is negative 0.93. 0.93. So my z-score, 0.93. Negative. Now this next one here, we have 14.92. That's in the positive, right? But it's symmetrical, so I could look at this. If I said negative z1, that's over here. So I'm just going to look up what negative z1 is. Okay, and if negative z1 would have to be the same thing as 14.92. Or also, what I could also do is go this, subtract 100 to find the rest. There's two ways of doing it. So first I'm going to look up 14.92 in the negative side. So we'll take our table again. I'm going to look up 14.92 in the negative. There we go, 14.92 is right there. That is negative 1.04. So we have this is negative z1 is equal to negative 1.04. Well, negative, we want positive, divide both by negative, so z1 is equal to 1.04. The other way of doing it is I could have gone 100%, subtract 14.92, and then looked up that one and found the positive z-score. And that would have given me all of this here. Okay? That's the other way of doing it. All right? Now here is the last one. Or second last one. We're going to look at C. Now, it says all of this here is 0.285. That's interesting. All of this here is 0.285. And that's all the way to the mean. Well, what is the other side of the mean? The other side of the mean is 0.5. Okay? So altogether, the probability of Z1 is equal to 0. Add this, 5 plus 0.2580. which gives me 0.7580. So now I have to look up that in my z-score. So we take this book here, and we want 0, and we know it's positive. 0.7580 is 0.700, right there, 7580. And that is my z-score. Z1 is equal to that. Last one here is a tricky one. Okay, so first of all, I can figure out what Z1 is, right? It's all of this, everything less than that. Well, if I can figure out that, maybe that'll help me find out Z2. So Z1 is everything less than that. This plus this is everything 50%. All the way to here is 50%. So all of this, subtract 50, will give me that there, right? All of this here, subtract 50, will give me that. So I'm going to go 0.5, subtract 0.2145, then I'm going to subtract 0.1292. Okay, don't really have a calculator here, so I'm going to have to do this very quickly on the side. Nope, 0.2195, and I have 1292, so that's 7, that's 8, oops, 8, 4, 3. So I get 0.5 subtract 0.3487. Now I look at that. And then subtract this. So I have 9, so I have 3, 1. Now 3, 1. 5, and 1. So that gives me 0.1513. So now we have to figure out this probability is Z1's actually everything less, okay? Because this is all 50%, and we're missing this part of the 50%, so that is the Z1's probability. That's what makes this one challenging. If you don't quite get this, don't worry about it yet. Now, 0.1513, 0.1513. And that's the probability, so we're looking at this section here. 0.1515, I have that there. Well, that's fairly close to this here, isn't it? 0.1515. Yeah, so I'm going to say it is, unless I made a mistake somewhere in my adding, 0.1515, that's the closest. I'm going to say it's negative 1.03. So we have negative 1.03. The Z1 is equal to negative 1.03. Okay, so now I know this is 1.13. I can find this here, this Z2. Okay, Z2 is equal to 50%, because this whole half is 50%, minus 1513, oh sorry, it's not equal to 50%, sorry, it's equal to this, all of this here plus that. So 0.2145, well, I'll just put that right there, plus 0.1513. Why? Because this plus this is everything less than Z2, and that's what our probability is finding in our table. So I add this together, and I get 0.3658. So let's take a look at that, 0.3658. So we look here, 0.3, whoa, it's over here, 6, it's in between this here, so which one is it closer to? 3658, I'm going to say it's closer to this one here, so 0.34. I'm going to say negative 0.34. So Z2 is equal to negative 0 or 0.3, no, sorry, what is it equal to? which one did I say? 365. So 365 negative 0.34. 0.34. So it's negative 0.34. So that was right. Okay? And that's how we do all those. Good luck on your assignment tomorrow. I hope you understand. If you have any questions, don't be afraid to ask. Or if you're lost over anything.